hospital need it, it's on the website there at that link for you to reference. Our objective today is to talk about performing preventive maintenance on oxygen concentrators, also basic troubleshooting and corrective maintenance for oxygen concentrators, and we'll talk a bit about the proper disinfection of respiratory equipment between patients. Again, this is a refresher session meant for someone with a strong background, but if you have further questions, please feel free to let us know, and we can try to cover more. And with that, I'm going to turn it over to Guna.
Hi, everyone. So, oxygen concentrator. So basically, when you talk about oxygen concentrator, you need to know about, it's called material that they use is Sieve to absorb nitrogen from air. So, and amount of nitrogen is more. So it's going to absorb by the Sieve absorber, depend on the pressure and the gas. So the more nitrogen being absorbed, you get better chances of oxygen to go through. So that's how it works. So air consists of 79% of nitrogen and 21% oxygen, atmosphere air. So that's how it works. Sieve tank normally absorb nitrogen and let go the oxygen. So you get more oxygen output. Normally, when you talk about oxygen concentrator, you're going to see like 5 solenoid valve that control the flow of the gas through the device, 2 feed valve that allow the air to enter. Another 2 more is to send out waste. Sometimes you're going to see 3, only 3, 1, 2 combination of feed and waste, and 1 is equalizer valve. So this is how the schematic look like. You got air input, then you got bacteria reservoir, all that. Then you got valve, you got all this pump system that use on the system, and it's going to go through the heating, cooling element, all that, and go through the Sieve tank. If you see the green diagram on your side here, you're going to see how the valve and the Sieve pump is working. So you got like input going through the Sieve tank, and the particular nitrogen will be absorbed, then oxygen is let go, and the waste will go through the E channel. That's how it works. So this is the schematic diagram of the oxygen concentrator. This is how it look like. It depends on the model and specification. Some of it you got additional sensors or control valve, or maybe extra flow system. Okay, main part of oxygen concentrator, you're going to see pressure regulator, compressor, solenoid valve, 2 Sieve tank normally, blowdown muffler, mixing tank, or they call it product tank sometimes, Flowmeter, and oxygen outlet. This is how what you're going to see inside your oxygen concentrator. So this is the oxygen concentrator specification that normally when your hospital purchase all that, you're going to see all these particular details, like the oxygen purity will have to be more than 93%, some of it 95, depends on the brand and model. Flow splitter. So for oxygen supply specification, you can add on flow if you got, particularly your oxygen concentrator got extra output, all that. So you can add on more flow for more patient control actually. Flow meter. So this type of flow meter is normally you can see on oxygen cylinder sometimes. Sometimes you ended up seeing it in the particular oxygen concentrator itself. So it depends. Humidifier, non-heating. These are basically used in the oxygen concentrator. Normally you need to keep clean this particular item because every time the water can change color, all that. So every single patient that you use, better clean the water, keep it clean. And I seen an incident that changed color, all that. So always keep it clean. Nasal prong is single use, normally used on the patient. So these are items that normally going to use on the patient with the oxygen concentrator and humidifier. Catheter is same thing. It's a single use item as well. Ventricular mask, it depends. They got non-sterilized and single use. Some of it they got multiple use. Depends what type of ventricular mask you buy. And they got multiple size as well. Oxygen mask, same thing as well. It's almost similar to ventricular mask. Working principle of oxygen concentrator, basically, when you talk about oxygen concentrator, you need to know the alarm system. So most of the alarm system in oxygen, you will basically notify you power disconnect, high pressure, some of it, even they have an oxygen purity indication, depends on the brand and model. Okay. So on the alarm system, they got low pressure oxygen. Then oxygen concentrator, I think I did mention earlier. So that's one of it. Blowdown muffler. These are normally is near to the compressor unit. So what happens is to control the noise and clear the waste in the proper way. So these are mostly to flow through the nitrogen through this particular thing. So normally the common problem is you get loud noise and increase of pressure on the system. So you can check this particular blowdown muffler. It happens because the lifespan of this blowdown muffler is like, it can be 2 years. Sometimes due to too much of moisture on the area, all that, it break up very fast, and eventually you get pressure increase and noise. So this is how the blowdown muffler look like. At the bottom of your compressor unit, you're going to see a blowdown muffler. You need to remove your compressor and remove this particular item. Normally, these are high pressure section. You have to remember that. Buzzer. Okay, buzzer is things that indicate the alarm, everything. So you need to look into it very carefully. You need to hear what type of alarm that you normally get. So you need to be careful. So that's some common problem that I see. What happened is some people think this alarm is annoying, all this. They ended up cutting the alarm, but they don't really troubleshoot the problem. So I seen this type of case, most of it. So try to avoid this type of mistakes. So the buzzer normally indicate some issues. You need to refer to your manual as well. Circuit breaker. Circuit breaker, when you talk about oxygen concentrator, they always design with a circuit breaker into the system to make sure if any pressure change or any compressor issues is going to shut down the system. So it's very important because a spike or surge current is going to shut down the particular circuit breaker. So this is how to remove the circuit breaker. As usual, you have to power off and remove the cover and disconnect and replace all that. Compressor, these are one of the main part of your oxygen concentrator. So it works to create pressure and to move your nitrogen into your serviette tank, all that. So it's play a very important role with your pressure swing observation, all that. So you need to make sure the compressor is always clean and work properly. Remember, do not use oil in your compressor. Refer to the manual. Some manual will mention what to do. Because you are dealing with oxygen, remember compressor, when you put oil, it's quite dangerous. It can burn the system actually. Okay. So this is how the compressor look like. So you got a flapper, valve flapper, all these. These are important part inside the compressor. So you need to keep it clean, all that. Make sure the dust on the top, all that need to be removed, all that. So this is how the compressor look like. When you break down more detail, you're going to see a piston and the cylinder head, all that, and the rod. So this is actual flap and the cup seal, all that works. This how it look like inside your compressor with the piston rod, all that. Flowmeter, everyone, they know front part of your oxygen concentrator. Flowmeter that control the flow. So you got 0 to 5 liters, some 8 liters, depends on the design and the brand. So these indicate how much of flow that going through the patient, all that. The ball going to float on the system when you do some setting on the valve. So flow meter setting, you have to refer when you set 4, it should be on the middle point. At the same time, if you want to know your flow is good or not, this particular reading have to be stable. The ball should stay in one place properly. You shouldn't go up and down. That means the reading is good actually. That means there's no pressure issue, low pressure or high pressure issue. At the same time, it indicates the flow is good. So when you talk about flow meter, how to remove it, you need to take out the cover at the back. You have to remove that particular point of the flow line, all that. So this is how you do it actually. These are basically instruction how to remove your flow meter. So high low pressure switch. Okay, high low pressure switch is basically indicate any changes of pressure on your system. So it's going to communicate with the circuit board and indicate with the alarm or with the light indication. So high low pressure will basically monitor your circuit, your flow line in the system. So this is how you replace high low pressure switch. These are the steps. You need to power off and remove all that. Hour meter is basically telling us how many hours the particular oxygen concentrator works. And this is how to replace the hour meter as well. But normally hour meter don't break easily. It works quite long actually. So this is your reference point when to change your oxygen filter, your system filter, all that you can indicate by the hour filter. So this is how you remove the hour meter, all that. So intake resonate is basically to reduce sound level of the compressor as well. So it's going to send particular air through the particular compressor, so to cut down the sound actually. That's the only purpose. Mixing tank, very important. Remember I spoke about earlier about flow meter reading is going up and down. So if your mixing tank have something fluctuation issues, you can see through your flow meter as well. The reading not going to stay stable, is going to fluctuate. So when the fluctuation happen, that means something wrong with the mixing tank or the product tank. So you need to look into this particular area. Normally, these are normally placed between the Sieve tank. The output of oxygen, you're going to see this particular mixing tank that collect all the output that's sending through your flow. So this where normally you're going to see the mixing tank located near to the high low pressure switch. So that's the place that normally they fix. At the same time, these are method of removing the mixing tank, what to do, all that. On off power switch, it basically is how to replace the on off power switch. Normally, if you check the switch is not working properly, you can replace it. This is basically the procedure of replacing on off power switch. So this is the location of on off power switch. Always remember, power off your system, then remove the on off power switch. Do not power on and removing the on off power switch. Maybe someone going to get electrocuted. Safety first. Printed circuit board. Okay, this is one of the design. Some design maybe will be different according to the brand. So this particular circuit will indicate and will control the particular valve, the 5 valve, the intake valve, waste valve, and stabilizer valve. So and some of it will monitor your oxygen and the pressure as well. Product filter is basically to remove particles from the product gas stream from the output. So these are basically, you have to replace every 50,000 hours. Sometimes what happens is, because of the product filter you don't replace, it become too hard and it create a high pressure system. So you need to replace this product filter 5,000 hours. But at the same time, if we are using near to the area with a lot of water or moist, the product filter lifespan can reduce. Be careful with that. Product regulator. So product regulator is basically located near to the mixing tank as well. So this is basically to adjust your pressure supply to the flow control to ensure the steady of the flow. Okay. Sieve bed is very important part of your oxygen concentrator. So after your compressor, sieve bed play very important role. This is where your air is pushed into the sieve bed and oxygen, nitrogen is been absorbed by the sieve bed, and the oxygen is let go. So that this is very important part of it. Normally, some of it you complain because oxygen purity is very low. It can be because of sieve bed lifespan have is basically the lifespan have done, or maybe because of the location that you use is too much of moist, it become harder inside the sieve bed, so the lifespan is done basically. So this is very important where your oxygen purity is done. And you have to remember, sieve bed normally you can replace, or sometimes you can buy the particular material itself. Depends on the country. Some country don't allow to bring it in. So this the breakdown of Sieve bed. Be careful with the Sieve bed. When you open, there's a spring, all that, and the O-ring you have to be careful, because when you fix back, you have to make sure no leaking. At the same time, when you open, you have to be careful. The particular spring can jump quite fast. Maybe you can injure someone. So be careful with that. So symptom of severe bed is basically caused by high pressure and low pressure concentration, and leakage on the system, breakdown of cycle due to the circuit board failure, caused by overdrawing the system, existing unit flow capacity, and movement of serviette bed material with the serviette bed itself. So remember, when you talk about serviette bed, water always will go through that particular system, basically humid. So if you are near to the very high humid place, the lifespan of your serviette bed is much more shorter actually. So to replace the serviette bed, basically you need to remove the pipe tubing, all that. So this is how you do it. This is the procedure of removing. So for serviette bed with the retain ring, do not attempt to open them. Basically, do not open the serviette bed because someone can get injured. If you want to open, you have to be careful with that. So do it carefully. Solenoid valve, okay, like I mentioned earlier, solenoid valve, you got high pressure, then the waste solenoid valve and the equalizer valve are normally used in your system. So if your filtering system is not working properly, solenoid valve, sometimes what happens is it failed due to the some dust or anything go into the particular valve and it doesn't lock properly. That can cause a low flow indication, sometimes high pressure or low pressure on the system. That's one of it. And very important, you have to check the coil. If sometimes because of the coil breaks, the solenoid valve not going to work. So you need to look into that particular solenoid valve. Then the O-ring of the solenoid valve, sometimes wear and tear will break as well. So this is how the solenoid valve look like inside. So you got O5 open ring and coil. So these are normally where the system will fail because the coil become weak due to the voltage application. So it's not going to close and open properly in long run, and eventually it fail. So this is how you change your solenoid valve. So basically, this is the detail that show how to disassemble and removing solenoid valve and fixing back the circuit, all that. Thermal switch is one of the important part inside the oxygen concentrator. So what happens is if your fan inside the thermals inside the oxygen concentrator is not working properly, or something wrong with your compressor, this particular thermal switch going to trigger and power off the compressor. So this particular thing is like a protection for your system. So it's ended up going to give you a low pressure alarm because the compressor have stopped working. Even though the fan inside the compressor, inside the oxygen concentrator is turning, but the compressor failed to work due to the thermal switch fail. Sometimes the thermal switch break because of high surge, all that, it failed to work. So you need to replace the thermal switch. So this is how you replace your thermal switch, the method of doing it, the procedure. So clinical user, what's the purpose they're using it? So What is O2 therapy? Is basically oxygen therapy at administration of oxygen concentrator greater than the room air to prevent upset of the patient. Basically, should be above 21%. So normally, oxygen concentrator is going to give you somewhere 93 above or 95 above percentage purity. Preventive maintenance. This is always interesting part for BMAT. Normally, when you talk about preventive maintenance for oxygen concentrator, you need to have digital pressure meter, oxygen analyzer, and multimeter. And very important screwdriver because you have to open up the unit. But normally for test tool, we need these three to verify the performance test of it. So these few biomed technician and biomed engineer that using oxygen concentrator to verify what's the purity of the oxygen concentrator. So this is how they do it with the checklist, all that, they verifying the particular unit. So sample of test report. When you talk about oxygen concentrator, normally you're going to set your flow setting 1 to 3 liter per minute. And you're going to see whether the reading is at 95%. So that's a tolerance 92 to 96. So when your flow change, your reading of the purity will change as well. The higher the flow, the purity reading can be lower. Remember that. And the cycle pressure, you got from low pressure valve, from high pressure valve. So these are basically depends on the brand and the model. Some, they will give you low pressure measuring point and high pressure measuring point. Some only give a low pressure measuring point as only. And they got battery test load alarm for 5 seconds. When you power up, the particular buzzer going to give some alarm. So that's the 5-second alarm. Power failure alarm, when you remove from the plug point, for the oxygen concentrator plug point, you remove, you're going to get some alarm as well. So that's to check power failure alarm. So inside oxygen concentrator, normally you're going to see a 9-volt battery. So you need to measure that particular battery with your multimeter to check whether the voltage above 7.5 voltage. So this is a high pressure test. So normally you're going to see high pressure test at the bottom of your serviette tank near to the compressor. So this is where you use your digital pressure meter to do it. But what normally this particular thing take place when you got issue with the high pressure output. And low pressure is basically you are measuring at the near to the flow line. So basically you are checking the low pressure section near to the mixing tank and product regulator. So these two particular measurement, high pressure and low pressure, normally done if your checklist reading on your oxygen purity is not in the range. If the range is not good and you got alarm, all that, you need to do this particular test to verify whether your low pressure point is any leakage, or high pressure point any leakage, or too much of pressure. So you need to check this particular point. So troubleshooting. Normally, what's the problem that you're going to find in your oxygen concentrator? Low concentration of oxygen. That's very common. Compressor doesn't run. Constantly got alarm with the on-off power switch. When the on position, you're going to hear some alarm, but the compressor not running. Low concentration oxygen, it can cause due to the serviette tank, or maybe due to the pressure or low pressure, or maybe sometime leakage. So low concentration can be because of these particular reasons. And maybe the Soviet tank itself, the lifespan already done, end of lifespan. So the third one, when you talk about troubleshooting guide, so we did put a troubleshooting guide with the particular flowchart. So when you talk about low purity, check and adjust the flow, measure the air pressure at the air test port. So if it C is low, check the internal filter, check for leakage, check for compressor, then the air pressure, check all this. If got leakage, clear it. If got high pressure, check the Sieve bed, check the control valve, check the muffler. And you go back, see if it's normal condition or not. So this is basically a troubleshooting guide to make your life easier. So if you follow this particular way of doing things, maybe you can troubleshoot much more faster. Right?
Okay, I think that's the end of our didactic presentation. I wonder if the Musoma team is ready to present. I'm happy to run the PowerPoint for you.
Okay, we are ready to present. Thank you so much. My name is Benedict Biseko from Musoma, Tanzania, and I'm so happy to have this moment with you. As well, to say special thanks to the people who have joined, and I want you to know that it is very, very encouraging to be together at a time like this. But also to say thanks to the wonderful team I'm having at Musoma Hospital, the engineers, for the incredible job which they are doing. So today we are going to share the experiences on doing effectively preventive maintenance on oxygen concentrators of our Musoma Hospital. So the learning objective, by the end of this presentation, the participant will be able to well understand all procedures taken during planned preventive maintenance of oxygen concentrator, understand all common problems associated with oxygen concentrators, as well as understanding all challenges facing biomedical engineers and technicians. Ellen, move to another slide. Thank you. Oxygen concentrator is an electrically operated medical device which provides purified oxygen. This device works by pumping indoor air into a container that separates oxygen from room air and concentrates it to provide oxygen continuously to users. The concentrated oxygen is then corrected in a tank and finally applied through a flow regulator to the patient. To another slide. Thank you. This part has been explained by our fellow Mr. Guna. So I'd love to move on to another slide so we can have the items which were not discussed earlier. Move to another slide. As well, the principle of operation. Guna explained all the principle of operations. Move to another slide. And to another slide. We want to share with the team, yes, exactly. So these are the PPE, during doing preventive maintenance, the following are the PPEs which you have to use, and especially during this moment of COVID-19. So those are the PPEs. You can see the blower, you can see the goggles, the mask, you can see the gloves. Move to another slide. Thank you. So the following are the procedures to be taken during doing planned preventive maintenance of oxygen concentrator. First of all, you have to do the physical inspection. Physical inspection involves checking all physical condition of the unit. Like first checking the unit housing or casing, change filters, check the power cord, alarm labels, and clean line and cleanness, and etc. As you can see from that picture which you have put, oh sorry. Okay, yeah, I wanted to show you that you can see all the things which I've mentioned from number 1 to number 7 on that picture or the image which we have put on our presentation. Move to another slide. So during physical inspection, general cleanness is performed including blowing inside parts by using blower. So you can see now the inside part of the oxygen concentrator. So you have to do blowing to remove all the dust. And this you do during the first part, which is physical inspection. Move to another slide. The spare parts are required during PPM. You can see all of the filters. Those are the spare parts mainly needed. Move to another slide. Okay. So the physical inspection checklist look like this. That is the picture of the physical inspection. That to do the proper preventive maintenance, you have to do the physical inspection. And that is the checklist which we have done to one of our unit, emergency unit, for one of the concentrator. And you can see it clearly. It guides you on how to do the physical inspection on the machine, on especially the oxygen concentrator. Move to another slide. So now we moved to from physical inspection. Now we have to go to electrical safety. You first do physical inspection, then second you do electrical safety. And this part you have to use electrical safety analyzer to perform the activity. Also by electric current. The main hazard is electric shock. Sorry, back to the slide, the previous one. Yeah, so electrical safety analyzer is used to check the electrical safety of oxygen concentrate. From the picture, you can see that is one of our champion, electrical engineer, Mr. Bartromeo. He was doing the electrical safety using the electrical analyzer, which you can see there, the pointer. Thank you so much. That is our electrical safety, which we're having at our facility. Now move to another slide. So to do now electrical safety checklist, you have to have that checklist. Is those are standard checklists to make sure that during doing the parameters, you follow the guidelines, the standard guidelines for oxygen concentrators. So those are the checklists which we're using, doing electrical safety to oxygen concentrators. To another slide. So now we come now to the most important parameter. We have seen physical inspection. We have come to electrical safety. Now we have to see to do the last one, which is performance test, to make sure that the output which goes to patients are exactly or are correct, or the outputs are up to the standard. I mean the standard, the manufacturer standards. So the oxygen analyzer is used to check the performance of oxygen concentrator, and it does checking the output flow setting, as you can see. From -1 to 3, it has to be 92% to 96. From -4, it has to be 89 to 96% of oxygen. From -5, it has to be, oh yeah, that's nice. It has to be 87 to 96. To another slide. So the performance test checklist, those are the standard checklists which we use to make sure that the performance now test is well equipped. So you can see from the checklist there, those parameters which I've mentioned, they are within the checklist. So you do the measurement and you refer there to the checklist to make sure that the device is within the range. Move to another slide. So now we have seen 3 parameters to do effectively preventive maintenance, which are physical inspection, electrical safety, and performance test. Now the following are the common problems associated with oxygen concentrators. And this part has been covered by Guna, Mr. Guna, so we have to move to another slide. As well as this part, he covered all. Poor handling, he covered it. User error, he covered it. Okay, so these are the major challenges that we have at our facility. The spare parts and availability. For example, the filters, sensors, tubes, zeolite material, capacitors, and I will mainly go to zeolite materials. We are having the number of oxygen concentrators up to 40, but 24 are working properly, and 16 are having the problem of replacing the zeolite materials. So this is our major challenge which we are having at our facility. And another one is improper handling of oxygen concentrator, these to users. And some users try to attempt technical activities. So the team brought it up to hear from you, from your experience. If some of you have done the replacement of zeolite materials, or have done, or how do you associate, how do you train the clinical people not to do technical activities to oxygen concentrators? Move to another slide. Fight against COVID-19. This is the end of our slide, but mainly objective of today, we wanted the engineers never to forget to use test equipment while doing preventive maintenance to ensure that we have light outputs from our oxygen concentrators, to use light tools, to use PPEs, and to use what else? Exactly. So this was our main objective of today, as well as for them to share experiences with us on how they do, how they change the zeolite, or if they have done it, and the impact of it. Thank you so much, Erin.
Awesome, thank you guys so much. That was a great PPM presentation. So we're gonna open it up for discussion. I'm sure there are a lot of questions. We went over a lot of material. Guna, I want to go back real quick and just clarify one thing on the PMs. When it comes to this unit here, do you wanna go over that briefly?
Okay, these are basically the oxygen concentrator flow output setting. So these are normally 1 to 3 liter per minute, and the flow can be 92 to 96, and 4 liter per minute can be 89 to 96, and 5 liter per minute can be in 87 to 96. So the flow increase, the oxygen purity can reduce as well, because you are pushing too much of air into the system. So what happens is when too much of the air, the serviette tank start to work more, and chances of producing the purity can reduce a bit. That's all. But as long as inside the range, that's a great result will be. So basically, you should be in that particular range. Actually.
Awesome. And maybe one other thing you could talk about is replacing zeolite, as that was identified as a challenge at the Musoma team's hospital.
Yeah, zeolite is basically one of the biggest challenge. This is one of the main component inside your oxygen concentrator. But you still can buy the zeolite raw material and replace it. That's another way of doing it actually. But depends on the country. Like I think I did mention earlier that zeolite is you can buy, but whether your country can whether you can send it to your country, it depends on your how they agree with that. So logistic, I'm not sure, but I got experience done this particular thing in different country. So we replace that particular raw material. You open up and remove the old material, replace with the new zeolite material, seal it properly, check the leakage line, and use it back. It works.
Thanks, Gunam. I think Evilius had asked a question earlier. Evilius, are you still on the call? Would you like to pose your question? If not, I can read this out. Well, maybe I can read it out. Evilius is an engineer joining us from Kagera region in Tanzania. And Guna, he's asking that when you replace sieve beds of different sizes, will it cause an issue with producing oxygen on a particular model, and issues such as low oxygen alarms staying on for a while because you've replaced the wrong sieve bed on an oxygen concentrator, or the wrong size sieve bed?
No, yep. When your sizing change, what happens is you're going to get high pressure or low pressure. But if you are getting a same sizing, it shouldn't have any problem. But at the same time, you can use the old unit. You can open up that particular unit and replace the raw material of the severe. So replace and seal it properly, all that, it'll work actually. But you're using a wrong size, that can cause a pressure differ on the system. That can cause a low alarm and high alarm, all that.
We have another question that was posed to us. And the question is, Guna, how does one check the lifespan or lifetime of zeolite?
Okay, lifetime of zeolite normally is written on the manual. That's one thing. And you can follow the manual. But if you want to increase your lifespan of zeolite, make sure that you use places like less moist or wet surface. Do not put near to the where the water area, all that, so you can increase the lifespan of the serviette bed. And make sure you clean every time. Make sure the ventilation system inside the oxygen concentrator work properly, because heat can cause serviette bed become harder inside. So that's another way of keeping your zeolite lifespan longer.
Okay, we have another question that has come in. What is the compression pressure required during refilling of zeolite in a cylinder?
Okay, when you talk about compressing pressure is not necessary. You have to compress, because what happen is the system itself, they have that particular pressuring thing. If you see, there's a O-ring and a moving piston with the ring. That particular spring going to give the pressure inside the serviette bed. So that's how it works. So you are not necessary, you need to do any compressed pressure on the serviette bed.
Thanks, Guna. And I just wanted to let everyone know, I think Benjamin just launched a poll. That's a way for you to give us some feedback about what you valued in the session today and what you didn't. There's a few options also for demographics, which just helps us know exactly where everybody's coming from. So please go ahead and fill that out and we'll close it in a few minutes. I think we have another question concerning the great importance of sieve beds. Is it reparable when it runs out of its lifespan?
As long you got the raw material, you can do that, but make sure when you seal it properly without any leak on the side surface, all that. It will work actually. But you need to get the raw material, the severe raw material is.
You know, what raw materials are those, for those who might not know?
That's a name for it. I can get the name. They're selling for 1 kilo for $5 USD or something like that. Serviette. So it mentioned as a serviette material actually.
Awesome. I think we've got a troubleshooting question here. There is a popping sound from the oxygen concentrator. What could be the cause of that?
The popping sound is normally your valve. That can cause popping sound on the oxygen concentrator. It can be high pressure or low pressure section. Normally, popping sound happens on the high pressure normally.
Very cool. Another question from Uganda. Are there any infection prevention protocols available for oxygen concentrators being used for COVID-19?
All the accessories are single use. Do not multiple use a different patient, that you can avoid cross infection. Make sure you clean it and wipe de-infect the particular device. So that's very important actually. So single use accessories like cannula, all that. Some of the face masks maybe is sterilizable. Some are single use, but make sure if you use single use, do not reuse to another patient.
Good. And there's a bit more information on that particular question in our session 1. And so if you've registered for this call, I'll make sure that you get links to all of the videos. If there are any other questions, again, you can send those in the chat or you can raise your hand. There's a button on the bottom bar and we can call on you. Oh, and I do see a question about the poll. We cannot relaunch it or it will wipe all of the previous answers. But you can feel free to give us any feedback you have by email. And that email again is assisthtm@assistinternational.org. Okay, I think it seems like that is it, and we're just past the hour anyway. Thank you again all so much for joining us. This has been a really good call. I think the information is very valuable and we hope you do too. Again, we'll open to any feedback, any requests for additional information. We'll send out the recording for this session as well as the slides. And if you need checklists, we can send those out as well. Benjamin, would you like to close us out?
I still see some questions coming in on private chat. Since we're running out of time on this specific session, if you can go ahead and email us your questions, we will get responses out to all of you. And as Aaron mentioned, we'd like to do a few more sessions of these. So if you have any particular questions, I think there were some questions about the Sieve Beds, zeolites, and so maybe we can do another session just on replacing the Sieve Beds, or just around how to put, replace zeolites in an oxygen concentrator. So we can think of topics like that, but we will need to hear from you. But besides that, thank you so much for joining. If you have other biomedical engineering friends who've been through some form of hands-on training, have them join us. These are just refresher courses. These aren't meant to take you from having zero knowledge of oxygen concentrator to be able to work on it. If you've had some practical hands-on training sessions around this, around oxygen concentrators or the other equipment we'll cover, have them join us, and we're happy to put them through these refresher courses. At a little later stage, we'll come up with some more basic training delivered on a distance-based learning model, where you can go through and learn all the basics even if you haven't had hands-on training yet. But thank you so much for joining. We're thinking of all of you. Stay safe, practice proper hand hygiene and social distancing. Do what you need to do. We're thinking of you, and be safe. Thanks, Aaron. Thanks, Gunnar. Thanks, man.
Thanks.
Of course.
Okay.
Goodbye.
Thank you so much.
Thank you, everyone.
Can you hear me, Erin?
Yeah, I can. Hi, Maz.
Yeah, hi. So I just to remind, if you have shared the slides of the previous session on ventilator, because I kept receiving emails on that.
Yeah, I'll double check and make sure, but I think Megan may have sent it out already. She got the video yesterday. But those uploads, so it may be today that she's sending it out for real.